Seems like that's everybody that's going to make it today. So happy Wednesday. I have a couple of things on the agenda. So I wanted us to finish the notes for graphing secant and cosecant functions. And then I want to know if you had homework questions. I posted homework yesterday, but there's also full solutions. So I don't know if you got a chance to look at them. So graphing sine and cosine, and then the solutions, do take a look at them, because this would be like the whole thing. So we'll see if we have time for that. I actually haven't so far today, but anything's possible. All right, so we'll set this aside. And we started these notes. That's what we need to finish. And I think that we labeled these two, right? Is that right? So the tangent function goes from negative pi over 2 to positive pi over 2. And the cotangent goes from 0 to pi. Remember, the tangent is the sine over the cosine. So going from negative pi over 2 to positive pi over 2 gets us the full range of the sine values, and the cotangent is the cosine over the sine. And so going from 0 to pi gives us the full range of values of the sine function. Okay, so I wanted us to graph the parent functions first. So this happens to be third period. And the notes are graphing secant and cosecant. Functions. Okay, so we're going to start with example 1. And we're going to graph the parent function. So this is part A, actually. We're going to graph f of theta equals the secant of theta. And then we'll also state the domain range. Okay, so the first thing I want to remind you of is that the secant, I want to color code this so it's pretty awesome here. The secant is so we've got f of theta equals the secant of theta, and that happens to be 1 over the cosine of theta. So all of the information that we've been using to graph the sine and to graph the cosine is still going to be valid here. So the first step, if we set b theta minus h equal to 0, we get that theta equals 0 because this is a parent function, so there's no horizontal or vertical transformations. And when we plug this in, usually this step is pretty tedious, but in this case, we've got the secant of 0. And that's going to equal 1 over the cosine of 0. Which, remember, the cosine of 0 is the x-coordinate. So this will be 1 over 1, which equals 1. Okay, so our third step, is that okay so far?
Yeah, that's good.
Yeah, that's okay. All right, great, thanks. So our third step, we're going to have 4 additional points. So typically we would only have 2 rows, but I'm going to have the cosine row and then the secant row. So the thetas will be our usual parent thetas. Then we'll have the cosine of theta, and then the last thing will be the function itself, just so we can see how these things relate. 0, pi over 2, pi, 3 pi over 2, and then 2 pi. These are our usual quadrantal angles for graphing sine and cosine. So we came up with that this would be 0, and so this would be 1. And remember that the cosine of pi over 2, that's 0, but that means this will be 1 over 0, or a vertical asymptote. Are we okay with that part?
Yeah, can you repeat that one more time?
Yeah, so the cosine of pi over 2 is 0, right? Because that's, that's our...
That's the x-axis.
Yeah, the cosine is the x-coordinate, but pi over 2 is on the y-axis. So the x-coordinate will be 0. And so the reciprocal of that, or 1 over the cosine, would be 1 over 0, which, because we can't divide by 0, at least we don't know how yet, that gives us a vertical asymptote.
Oh, okay, that makes sense.
Is that okay? All right. So remember that the cosine of pi, that's this angle over here. This one is -1. So we have -1. And then our function, the secant, would be 1 over that -1. So that simplifies to just -1. So the cosine of 3 pi over 2, again, that's this angle here. That gets us 0 again, which means that we would have 1 over 0, or a vertical asymptote. So does that make sense? We can see how these two ideas are related.
Yeah.
Okay. So the cosine of 2 pi, that gets us 1 revolution of the circle back to the beginning, will be 1. And then the secant of that would be 1 over 1, or just +1. So far, is that okay?
Wait, so you're just using the, so for cosecant and secant, you just use like the graph rather than like finding y, like for like the tangent and like cotangent, because it's like different, right? Since you're using the graph instead of like plugging in values.
Yeah, so in this situation, these vertical asymptotes take the place of us having to find a lot of points, right? So because the pattern will repeat over the horizontal axis.
Yeah.
So what happens, we get, can you see all of this? Yeah, okay, so we've got pi over 2 and 3 pi over 2 and -pi over 2 and -3 pi over 2, right? So we have all of this. I'm going to count by half just so things are a little bit more spread out. But 0 is at 1. So I'm going to put this point here. Then pi over 2, we have a vertical asymptote. Pi is at -1. 3 pi over 2 is at 0, so that gives us another vertical asymptote. And then 2 pi will be at 1. So I can repeat this pattern on the other side. And notice anywhere that I have a point on the horizontal axis, that will be our vertical asymptote, right? So we have one here. And we'll have one here. And we've got one here. And we have one over here. So does that make sense? Every time we have 1 over 0, we would have a vertical asymptote because we don't know how to divide by 0 yet.
Yeah, that makes sense.
So our cosine function will be this. But the secant function will be like this. So the secant is the pink branches, and the cosine is the gold curve, the gold wave. Is that okay?
Yeah, so the VAs are like obviously like so pi over 2 and then 3 pi over 2, and then you have to do the same because it's a pattern, right?
Exactly.
And then he said, wait, so the secant is the like
Is these parabola looking branches that are coming off of the maximum and the minimums.
oh, I see. Okay, and then what about the original like pattern, like the curves?
So
Does that
this piece isn't actually part of it. We just use it to help us graph the secant and cosecant. So technically, the graph shouldn't even have the gold curve on it. It should just be these branches up and down.
Oh, I see. Oh, so those are kind of like the sine and cosine, right?
Exactly. That's their reciprocals, right? So the cosine, the secant is the reciprocal of the cosine, right? Like we set up here. So that's why the cosine functions in the graph. But really, the secant is just these branches coming off of the maximums and the minimums.
Oh, that makes sense. You can kind of think of it as like this reciprocal because it's like kind of like overlapping, like
Yes.
Okay,
Yeah.
that makes sense. I understand it.
Okay, cool. All right, so I will tack this down, and then we'll talk about the domain and the range. Okay, so the domain that goes dot, 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 the union, we've got what, negative 3 pi over 2 to negative pi over 2, and negative pi over 2 to positive pi over 2, and that goes pi over 2 to 3 pi over 2. And then that continues outward. And the range might seem scary at first, but I think that you'll be pretty comfortable with it once you see it. So from negative infinity to negative 1, bracket, because there's no reason that we can't use this negative 1 point, the minimum point. And then from positive 1 up to infinity. Again, bracket here, because that's not part of our vertical asymptote. Is that okay? Instant replay, anybody?
Wait, so the things like the curves on the right and the left of the graph is like it's half of like the I can't say that.
Yeah.
It's because it's like you're only taking up what's on the graph, right?
Right. So if I could shift this over in a panorama, then this would come up like this, and this would come up like this.
Okay.
Yeah, I guess technically I should have arrows there. This would go like that, and this would go like that. Is that better?
Yeah, that's good.
Okay, great. So we will try the cosecant. That's what we've got next. So f of theta is the cosecant of theta. So all the same stuff. We don't have any, we'll graph it and then we'll talk about the domain and the range. The thing that I want to remind you about is that the, so this is the same as 1 over the sine of theta. I guess I technically want this to be in my pink marker. So the cosecant of theta is actually 1 over the sine of theta. Okay, so the first step is that b theta minus h equals 0, which of course this is a parent function, so theta equals 0. Our second step, plugging that in. So when we do that, we've got the cosecant of theta. So the cosecant of 0, and that equals 1 over the sine of 0. So the sine of 0 happens to be 0. So this is going to be 1 over 0, which gives us a vertical asymptote. How are we doing with that?
That's good.
That's okay? That makes sense? Okay. All right. So our third step means that we have to come up with our additional points. So again, I'll use theta and the sine of theta, just so we can kind of make sense of the points. And then this will be our cosecant of theta. So we already used 0 in our first and second step. And now we have to consider pi over 2 and pi and 3 pi over 2 and 2 pi. Okay, so we got this to be 0 and this to be 1 over 0, or a vertical asymptote. So the sine of pi over 2, that happens to be 1. And so the cosecant of pi over 2 will be 1 over 1. The sine of pi, remember again, that's over here on the negative x-axis, so that will be 0, which means the cosecant is 1 over 0, or a vertical asymptote. Any predictions about the sine of 3 pi over 2?
That'd be 1 over 1.
So 3 pi over 2 is down here, right? At 6
Oh,
o'clock?
so that'd be negative?
-1, yeah. So this will be 1 over -1,
Yeah.
which is -1. And then the sine of 2 pi, again, that's 0 because it's the same as this, right? It's just 1 full revolution. So this gives us 1 over 0, which is another vertical asymptote. Any questions about the table? I will pause for a second so you can copy all of this down, and you can either turn on your mic or you can chat them. Okay, seems like we're all right. Or we have so many questions we can't articulate any of them, so I guess I'm hoping that's not the case. So we've got pi over 2. We're counting by our same quadrantial angles here. And I'm going to count by halves, again, just so things are kind of spaced out nicely. Okay, so we said we've got a point pi over 2 is up at 1. 3 pi over 2 is at -1. We know that this is going to be a 0. This is a 0. That means this is -1, 0, +1, 0, and that's 0. So every time, all of this is a vertical asymptote here, and here, and here, and here, and here. So let's draw those in, because it will help us get everything else right. Okay, so if I draw my sine curve, do you want me to draw it or you want me to leave it off? I'm gonna leave it off this time. I'm gonna
Yes.
leave it off. Let's see. We can add it later if we think we need it. So this is the cosecant. There we go. So that's our graph. Questions about that one?
It makes sense. Wait, so why are we not drawing the sign? Oh, because we can just do the
Yeah, so we totally can draw it if we want to,
yeah.
but I felt like the different color inks I'm using aren't showing up as vividly as they are on my page. So I wanted to make sure that you understand that the cosecant is just these branches, these staggered branches, some going up, some going down. And where it comes from is the sine wave that we haven't drawn in. Like over here, we drew in the cosine wave, but
Yeah.
really the secant is just these branches going up and these branches going down.
Okay, so we already know to draw the maximum.
Right. So. Yeah. Does that make sense?
Yeah.
Okay. So the domain and the range, that's what we have to do next. And then we can roll the dice and come up with some monster secant and cosecant functions. And okay, so our domain here, it goes dot, dot, dot. We have what? Negative union, negative 2 pi to negative pi, union, this will be negative pi to 0, union 0 to pi, union dot, dot, dot. So that's our domain. And then the range just looks really intimidating. Negative infinity, comma, negative 1, bracket, union, bracket, 1 to infinity, parentheses. So that's that part. That's okay. Can you give me a thumbs up if we're okay and we're ready for something more complicated, or if we're not? So that looks good. That looks good. Okay, thank you, Emmett.
So the domain is just like the vertical asymptotes, right?
Exactly.
Okay, and then so like the range is, why is it negative infinity to negative 1 again?
So these go on, and then they stop at negative 1. And then there's nothing in here because that's all the sine. For this one, it's the sine wave. And
no, okay.
And then it starts here and goes up.
Yeah. Okay.
Okay, cool. All right, so let's make an example 2. So we've got example 2. So we'll graph whatever crazy function we have here, f of theta. Let's see what we get. And we'll do the description. Oops. Okay, nice. That won't be terrible, I think. So negative 4. We maybe want that to be different. Let's roll that one more time. Okay, 2/3, that works for me. And then, okay. All right, so here's our function. So f of theta equals negative 4, the secant of 2/3 theta plus 5. So that's our function. Okay, so part A, I guess our description, right? So I noticed that A equals negative 4. That's a vertical stretch by 4. And it's because it's negative, it's a reflection over y equals 5. Also, I noticed that b equals 2/3, which will be a horizontal stretch by 3/2. So far, does all that make sense? K equals 5. This is a vertical shift up 5. Is that part okay?
Yeah, that makes sense.
All right. Part B, we'll do the graph. So the first step, again, we set b theta minus h equal to 0, which 2/3 of theta equals 0, which means theta has to be 0. Our second step, when we plug in, so that gets us, I'm going to go slow here, -4 times the secant of 0 plus 5. That is the same as -4 times 1 over the cosine of 0 plus 5. Okay, so the cosine of 0 is 1. So we have this -4 times 1 over 1, which is 1, plus 5. That leaves us with just 1. Everybody okay with that?
Yeah.
Okay. Our third step will have 4 additional points. So we've got our usual theta, our thetas that will graph because of this horizontal stretch, and then our y coordinate. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we already found that this would be 0 and this would be 1. So now let's find these shifted values. So we've got 2/3 theta equals pi over 2. And when we multiply by the reciprocal, we'll get 3 pi theta equals 3 pi over 4. So moving on to our next value, 2/3 theta equals pi. And when we multiply by that reciprocal of 2/3, we'll get theta equals 3 pi over 2. But I really like it when the denominators are the same. It makes it easier to choose the horizontal increments. So let's multiply that by 2 over 2, which gets us 6 pi over 4. Okay, so our next step is 2/3 theta equals 3 pi over 2, which again, multiplying by the reciprocal of this coefficient 2/3 means that we will have 9 pi over 4. And then our very last value, 2/3 theta equals 2 pi. And that gets us theta equals 6 pi over 2. Hold on a second. Yeah, 6 pi over 2, but to get our common denominators, we're going to say 12 pi over 4. Okay, so we've got 3 pi over 4 here. We've got 6 pi over 4 here. We have 9 pi over 4 and 12 pi over 4. So now these values okay, so we have our function is negative 4 times the secant of pi over 2 plus 5. So notice this is negative 4 times 1 over the cosine of pi over 2 plus 5, but the cosine of this angle that's entirely on the y-axis will be 0. So we'll have a vertical asymptote here. Okay, so the next one, negative 4 times the secant of pi plus 5. Remember, this is negative 4 times 1 over the cosine of pi plus 5. The cosine of pi, that's negative 1. So this whole fraction becomes negative 1. So negative 4 times negative 1 is 4. 4 plus 5 equals 9. Questions about that one?
That makes sense. Because
Hello?
Yeah.
cosine's on the x-axis.
Hello?
Yes? Juliet, do you have a question? Is Juliet saying something? I can't hear her if she is. Okay. So Juliet, you can chat your question as well if you have a question or a comment.
My screen just kicked me off and put me back on for a second.
Oh, okay.
I don't know, just technical fun, I guess.
Yeah. Oh my gosh. I sympathize. Okay, so our next angle is the 3 pi over 2, which we know also is on the negative y-axis. So this will be 1 over the cosine of 3 pi over 2, but we know that's going to be 0. So that gets us another vertical asymptote. And then our very last value is negative 4 times the secant of 2 pi plus 5, and this will be negative 4. Now this will be 1 over the cosine of 2 pi, but the cosine of 2 pi is 1. So 1 over 1 is 1. So negative 4 times 1 is negative 4. Negative 4 plus 5 is positive 1. So let's see, we've got a vertical asymptote here. We've got 9 here. We have another vertical asymptote. And then our pattern returns to 1. So I can see a pattern here on the theta to graph. I can also see a pattern in my y coordinates. So I'm feeling pretty comfortable that I haven't made any mistakes. Okay, so we will set up our graph with, it looks like, that's annoying. That's not a thing. Okay, with, should we count by 3 pi over 4? Will that do it? 3, 6, 9, 12, yeah, that should do it. Okay, so let's see, right here. So 3 pi over 4, 9 pi over 4, 6 negative 9 pi over 4. And we need to count by 2's, 4, 6, 8, 10. Okay, so what do we got? At 0, we have 1. At 3 pi over 4 is the vertical asymptote. At 6 pi over 4, we have 9. Then a vertical asymptote, and then back to 1. So let's see. Let's start to sketch this. So we said there was a vertical asymptote here. We said we had one here. Okay, so now we can see the pattern of where the vertical asymptotes are. So I predict we have one here. Oops. And one here. So now then, so this one goes like this, and this one goes like this, and like that, and like that, and then that should be here, and then here, like this. And then that would go like that, and that would go like that. How's that? Is that okay?
Yeah.
All right. So let's put the graph right here on the page. And domain and range. Okay, so the domain goes from ... union, what do we have here? Negative 9 pi over 4, comma, negative 3 pi over 4. Union, negative 3 pi over 4, positive 3 pi over 4. Union 3 pi over 4, positive 9 pi over 4. And then the range. So we've got negative infinity, positive 1, and positive 9 to infinity. There we go. Is that part okay?
Yeah.
All right. Anybody, thank you, Emmett. Anybody have questions? I'm gonna scroll. No. It's okay? Oh, great. Okay, so do you have questions from this homework, or because we said we were gonna do that? Do we have questions from any of this? Any of that look scary, or we're okay?
I'm good.
All right. Okay. Let's roll the dice, and we've got about 8 minutes here, so we'll see. Let's set up another one. So example, I don't know, I'm gonna want this all on the same page. Okay, so let's come up with an equation. Okay, so we've got a horizontal, a vertical, and all right. Plus 2, that's not terrible. Plus pi, okay, this is super great. And minus 3. All right, no problems. Okay, so we've got f of theta equals we're going with a cosecant this time of 2 theta plus pi minus 3. All right, so remember this is the cosecant of 2 times theta minus pi over 2 minus 3. So if this is plus here, just kidding. If I distribute that, I do get back to there. Okay, great. So the description, we've got b equals 2. That's a horizontal shrink. By 1/2. We've got h equals negative pi over 2. So that's a horizontal shift left pi over 2. And we've got k equals negative 3, which is a vertical shift down of 3, of course. So the next step is graphing it. So we've got 2 theta plus pi. If I set that equal to 0, I've got 2 theta equals negative pi, and theta equals negative pi over 2. So that's good. That's what we predicted would happen. The second step is we plug it in and see what we get. So we've got the cosecant of 0 minus 3. So the cosecant, remember this is 1 over the sine of 0, but the sine of 0 is 0. So that gets us a vertical asymptote. Does that part make sense? That's okay with everybody?
Yeah.
All right. So here are our 4 additional points. Usual theta. Our thetas to graph and f of theta. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we came up with this would be negative pi over 2 and a vertical asymptote. So the next step, we've got like 4 minutes left here. So we've got 2 theta plus pi, and that should equal pi over 2. So we've got 2 theta equals pi over 2 minus 2 pi over 2. That gives us negative pi over 2. And when we divide, we've got theta equals negative pi over 4. Okay, so the next one is 2 theta plus pi equals pi. So when we subtract that, we've got 2 theta equals 0 and theta equals 0. So next up, 2 theta plus 3 pi over 2. I'm just kidding. That's not right. That's pi. Scribble all that out. Equals 3 pi over 2. So 3 pi over 2 minus 2 pi over 2 equals pi over 2. And when we divide by that coefficient of 2, we have theta equals pi over 4. Yeah, okay. All right, so 2 theta plus pi equals 2 pi. And when we subtract this, we get that 2 theta equals pi. And that gets us that theta equals pi over 2, which I'm going to convert to 2 pi over 4. Okay, so we've got negative pi over 4 here. And we've got 0 here. 3 pi over 4 turned into positive pi over 4 through our transformation. And then 2 pi turns to 2 pi over 4. And I'm going to switch this to negative 2 pi over 4. Okay. Is that part okay? Can you give me a thumbs up if you need an instant replay, Kings? And I'll scroll, see if anybody's okay. Looks like we're all okay with that part. Great. So the y coordinates, we've got, let's see, where's our function? So the cosecant of pi over 2 minus 3. So the cosecant is 1 over sine. So this will be 1 over the sine of pi over 2. So this is 1 over 1 minus 3 is negative 2. The cosecant of pi minus 3 is 1 over the sine of pi. But the sine of pi is 0. So that gives us another vertical asymptote, which is good because we kind of have a pattern going here. So then we've got the cosecant of 3 pi over 2 minus 3. And this is 1 over the sine of 3 pi over 2. So this will be 1 over negative 1, which seems to be negative 4. Am I doing that right? So that's, yes, negative 4. Okay. And then the very last thing that we've got is the cosecant of 2 pi minus 3. But again, that'll be 1 over the sine of 2 pi, which is 1 over 0 minus 3, or a vertical asymptote. Okay. So I think we can graph this quickly if no one has any questions, or I'm happy to answer questions too. Okay. So this graph, pi over 4, 2 pi over, is that what we want to do? Yeah, I guess so. 1 pi over 4, pi over 4, 3 pi over 4. Negative pi over 4, negative 3 pi over 4. And count by ones on the y-axis. So let's see, we've got vertical asymptotes go. We have one here. And the other one is 0. And the last one is 2 pi over 4 here. Which means we've got one here. And we have one over here. Okay. All right, so negative pi over 4 is negative 2. Pi over 4 is negative 4 here. And so this is here, this is here, that's there. Perfect. Okay, so this one goes up like this. This one goes down like this. We have one here, just repeating the pattern now. And we have one over here. Again, this is just repeating the pattern. We didn't actually find points for that on our table. So that's our graph. Is that okay?
Yeah, that's good.
Thanks, Emmett. Thanks, Jared. Questions? Anybody have questions? No?
No, I think it's like overall like pretty easy once you get like the hang of it and just like patterns and stuff. So
Yes, it's the patterns and yeah, it's the unit circle again. All right, cool. So reminder, there'll be an Edmodo quiz and homework with tangent and cotangent on it. The Edmodo quiz will be about tangent and cotangent. So have those notes out, take a look at that homework before you do the Edmodo quiz, which will be due Saturday night at midnight. So other than that, I will see you on Friday.